Hi guys, welcome back. Today we'll solve problem number 2009, minimum number of operations to make an array continuous. The problem says we will be given an integer array. We will have to make that array continuous by replacing any element in the array with any integer you want. So for an array to be continuous, it has to follow two conditions. All the numbers in the array are unique. I mean, they should be unique. There should be no repetitive numbers in the array. And also the maximum number and the minimum number in the array difference should be equal to length of that array minus 1. In the given example, 4253, 4253. All the numbers are unique. Yes, so it is following the first conditions. And the second condition says the maximum number minus minimum number, which is 5 minus 2, should be equal to length of this array minus 1. So it is also following the second condition. So we don't need to make any changes in this array. So we can simply return 0 because we have not performed any operations here, right? So for the second example, 1, 2, 3, 5, and 6. Here, all the numbers are unique. Yes, it is following the first condition. And the second condition says the maximum number is 6 here and the minimum number is 1. So the difference is 5. But the length of the array is 5. So n is 5 minus 1, which is 4. 5 is not equal to 4. So this is not the continuous array. We need to make this array continuous. So to make this array continuous, we can replace this 1 with 4. Then the resulting array is 4, 2, 3, 5, 6. Here maximum number is 6 and the minimum number is 2. So the result is 4 and the length of the array is 5 minus 1, which is also 4. So by making one operation, we have achieved this result. I mean, we have achieved this to be a continuous array. So similarly, I mean, we can replace this 6 also with 4 and keeping it as 1. So, I mean, we can do anything. So the number of operations should be minimum, right? So how do we solve this? So if you observe these two conditions, we just need to make this array such that all the elements in the array should be in the range L comma L plus n minus 1. L being lower bound. So I'll explain what I mean by lower bound. So if you take any element in this array, and if you want to make that element as minimum element, let's say if I want to make 4 as minimum element, if I want to follow these two conditions of length 4, so the minimum element in the array should be 4 and the maximum element will be 4 plus 4 minus 1, which is 7. So it should be of range 4 comma 7, right? So the array will be 4, 5, 6, 7. So we need to have the elements, I mean, all the elements in that order. I mean, this order doesn't matter, but in the number line, whatever we have, 4, 5, 6, 7, we should have all these numbers in the array so that it follows this two conditions. Let's see the given example two one more time and see. So the second example 1, 2, 3, 5, and 6. In this example, if we take 1 as the lower bound, we should have all the elements from 1 to 1. The length of this array is 1 plus length of this array is 5 minus 1. So from 1 to 6, 1 to 5, we should have all the elements. Then only this array will be considered as continuous array. But if you see, we have 1 here, we have 2, we have 3, but we don't have 4. We have 5. So we have 6. So instead of 6, if we put 4, then this array will be a continuous array. So I mean, we don't need to take 1 as the lower bound. We can also take 2 as lower bound. So if you take 2 as lower bound, you have 2, you have 3. I mean, then the result will be from 2 comma 6. So you should have all the elements from 2 comma 2 to 6. You have 2, you have 3, you have 5, you have 6, but you don't have 4. So you can replace this one with 4. Then you have achieved this continuous array. So let's take 3 as lower bound and see if we achieve this lower bound or not. So if you take 3 as the lower bound, then the range will be from 3 comma 3 plus 5 minus 1, which is from 3 to 7. Okay. Now here 1 is not in the range. So we need to replace this one. 2 is not in the range. We need to replace this 2. 3 is in the range, 5 is in the range, 6 is in the range. So instead of 1, we can put 4 here. And instead of 2, we can put 7 here. So this is also continuous array, but we have done 2 operations. So we need to make these operations minimum. So thus our answer is still 1 by replacing 1 with 4 or 6 with 4. I mean, by taking 1 as the minimum number and 2 as the minimum number. So if we take 1 or 2 as lower bounds, then we have achieved this result. So similarly, let's take one more number and see how many operations we need to make. So here in this 1, 2, 3, 5, 6, if we take 5 as the lower bound, then the range should be from 5 to 5 plus 5 minus 1. So the range is from 5 to 9. Right, 1 is not in the range, so we need to do one operation. 2 is not in the range, so plus 1, we need to do one more operation. 3 is not in the range, so we need to do one more operation. 5 is in the range, 6 is in the range. So we need to make 3 operations in order to achieve if we want this 5 as the lower bound. So similarly, what we'll do, to solve this problem, we will take all the elements in the array and we'll try to see if how many operations do we need to make so that this array is continuous by taking that particular element as lower bound, right? So okay, now what are we doing? So we're just taking one element. I mean, let's say if we will take one element and then we will start iterating from that element and see if so. To solve this question, so we will take a lower bound. I mean, every element in the array as lower bound, and we will calculate the number of elements which are already present in the range if we take that element as lower bound. Let's say in this example one, uh, in this example one, 4, 2, 5, 3, we will calculate what if we take 4 as lower bound. So if we take 4 as lower bound, then the range will be 4 to 7. We'll calculate what all numbers are present here in the lower bound. So 4 is present, 5 is present, so which is 2. So we don't need to do anything for these 2 elements, and for the rest of the elements we need to make changes. So here we will change it to, so the n is 4, 4 minus 2, which is 2. So if we take lower bound as 4, then we need to make n minus the whatever the elements that are present in the range. So similarly, if you take in this array, if you take 2 as the lower bound, then the range should be from 2 to 5. So here, how many elements are already present in this range? 4 is present, 1, 2 is present, 2, 5 is present, 3, and 3 is also present, 4. So we will return 4 minus length. I mean, not return, the answer will be, if we take 2 as a lower bound is 4 minus 4. And we will keep track of the minimum value, and at the end, we will return the minimum value. But this approach will not work if we have duplicate elements in the array. So let's say if we have 2, 3, 3, 4. So if we have this array, so if you take, the range will be from 2 to 5. Now if you see, 2 is in the range, 1, count is 1. 3 is in the range, count is 2. 3 is in the range again, this count is 3. And 4 is in the range, now count is 4. So if we calculate answer, now the range will be 4 minus 4. The answer will be 4 minus 4, which is 0. But we need to replace this with 5, right? So we need to ensure that we have removed the duplicate elements before doing this solution. So yeah, first we will replace the duplicate elements, and then we will try to calculate the result. But what is the time complexity for this approach? So for every index, for every index, we are calculating, if we are at 4, we will be calculating for 4 how many elements are not present in the range, and for 2 also we will repeat the same, and for 5 also we will repeat the same, and for 3 also we will repeat the same. So the time complexity for this approach is order of n square. Can we optimize it? Yeah. So if we sort this array, right? If we sort this array, let's say if we have something like this, 2, 3, 4, and 5. By using binary search, we can find what is the element that is not present in the array. So let's say if for 2, if we do binary search and find the index of the element which is not present in the array, right? So the range will be 2 to 5 here. So if we find the index of the element next to this 5, or the whatever the element that is not present, then here it will be this one. Then we will understand. So all these numbers will be in the range. So whatever that is not present in the range, so we can simply remove these elements and it will be our answer. But for 2, when there is there are no elements outside the range. But let's take one more example and see. Let me clear this. So let's take this example of 15, 4, 2, 40, 7, 12, 3, and 2. So here the result, length of the array is 1, 2, 3, 4, 5, 6, 7, 8. But there are duplicate elements, so we will create a new array so that these duplicate elements are removed and the resulting array is sorted. So let's also sort this, and then the resulting array will be 2, 3, 4, 7, 12, 15, and 44. So now if you take 2 as the lower bound, then the range will be from 2 comma 2 plus 8 10 by 2, which is 11, right? So these numbers should be in the range from 2 comma 11. So let's calculate how many numbers are actually in the range, and we will subtract it from n, then we can move forward. So we know the higher range. We can do this iteratively to find, okay, I mean, here, okay, till 7 we have. From 12 these numbers are not in the range, so we will have to replace these numbers. So 1 2 3, so it will be 3. But instead of doing this iteratively, we can do binary search to find, okay, 11. Since this is sorted, we will do binary search to find the next index, and then we will calculate this index as j. So the result will be j minus I. So these numbers we don't need to replace. These are already in the range. So answer will be n minus this j minus I. So we will calculate this answer for all the indexes and we'll return the minimum. So this is the approach. Let's try to write the pseudocode for this. So first we will have n defined as length of the array, and then we will remove duplicates, and then we will iterate over the array for I equal to 0 to I equal to n. We will iterate when I less than n. We will iterate over the array, and we will calculate the right bound index. So we will take this as the left bound and we'll calculate the right bound index. So yeah, we will do binary search to find the index, and we will get this. Now we will calculate the number of elements we will that are already present in the element. I mean, number of elements that are present in the range. That will be equal to this right bound index, right bound index minus this left bound index, which is I. And answer will be length of this array minus this number of elements that are already present in the range. Number of elements. So we will calculate the minimum of all these things, and at the end we will return answer. So I'll write this pseudocode more neatly. So what are we doing? So we will calculate the length, and then we will remove the duplicates and create new array, and then we will iterate over the array. What we'll do, we will calculate the right index, right bound index, and then the number of elements in range will be equal to this right bound index minus I mean the current lower bound, which is I. And then answer will be equal to minimum of answer comma this n minus this one. So after iterating, we will return this answer. So I forgot. So after removing the duplicates, we need to sort the new array. Without sorting, we cannot apply the bound binary search, right? So yeah, this is it. Let's quickly try to implement this. Yeah, we will first calculate the length of the array, and then to remove the step 2 will be removing the duplicate element. So let's store all these elements in the set, and then let's iterate over the set again, and let's put those elements in the new array so that the duplicate elements will be removed. So I'm using hash set integer of unique elements will be equal to new hash set of integer, and now parent nums, we will add these numbers. And now this set we have only unique elements, so now we will take new array, new nums equal to new int of the size of the array will be unique elements dot size. Let's take index as 0 and for int num in the new nums in the unique elements. Let's add into new nums. New nums of ind equal to num and increase the index value. Now let's sort this. And the next step will be sorting the new array. So arrays dot sort new nums. Now let's initialize the result with the maximum number integer dot max value, and let's iterate over the array equal to 0 I less than new nums dot length I plus plus. So yeah, so here the right bound value will be uh, so I plus n minus 1, right? So we need to get index, we need to find this element in the new elements, where it is sort. So right bound index will be equal to, we'll need to search, let's implement this search later. Let's say that the search function will take new nums as an input and right bound as target, and it will return us the right bound index. Now number of elements that are in range, in range will be equal to, what is it? So this right bound index minus I. So yeah, and this result will be math dot min of result comma n minus number of elements in range already. So We have already these many events in the range, so we need to replace the remaining elements. So at the end, we'll return the result. Let's quickly implement this search functionality. So this will return the index. The name is search. We'll take an array of, let's say, array, and we'll have target to find, right? So as in binary search, we'll initialize left equal to 0, and then int right will be equal to array dot length minus 1. So while left is less than right, we will iterate over the array, and let's calculate mid equal to left plus right minus left by 2, and we'll check if array at mid, if this is greater than the target, then we need to move mid. We need to move right side to the mid, else we will move left to the mid plus 1. At the end, we will return left. So this is, so here we're just doing binary search of the target, and this should work. But I mean, right will be equal to array dot length. So now let's quickly run this and see. Yeah. So why right is equal to array dot length? Why no? Why not minus 1? So we need to return the next element, right? So yeah, if this target is present, then it's okay. I mean, we need to return the, if this target is present at ith index, so that I also is present in the range only. So we need to return the next index. So that's why instead of taking right as array dot length minus 1, we have taken as array dot length only. So yeah, let's quickly submit this. Yeah, it got accepted. So this the time complexity of this order of n log n. So as we are sorting this, this takes n log n time complexity, and also the space complexity will be n, as we are taking this new nums, and also here while iterating, so this is n, and for searching it will take log n. So anyhow we have n log n here, so it should be log n. So by using a sliding window, we can optimize this to n, but then anyhow we are using n log n time here, so it's okay if we do it here also, because it's ultimately n log n time complexity only. And yeah, that's it for this question. Feel free to drop any comments if you have any doubts. So thank you for watching. See you in the next video.